let me get to the science part now. So I thought, 60th birthday, you look around and so on. Of course, I'm a little bit younger than that, not much younger, unfortunately. And I thought that could have been something different than the usual talk. Could have been somehow perhaps a summary of some of the highlights, some of the research we've done, and look at these things a bit more critically. It's not a talk about networks, it's a talk about science, the quantitative study of science, which goes under many names, among others, science of science, which was actually the original name that Derek the Solar Prize gave to this endeavor. What is it? It's a study of the structure and evolution of science by analysis and modeling of data on scientists and their interaction. This is the manifesto of the discipline that we published a few years ago in Science magazine with a lot of nice people, including Dirk and Alessandro here, that I highlighted just on purpose. So it's a multi-author collaboration. Just to give you an idea, this thing has been translated even in Chinese, because there was big interest about this thing, was told. And the keys of this discipline is that you have massive new data sets, bibliographic data sets which have been around for a long time, but also that data about funding, about mobility, and now, of course, also data about context, right? The text of papers that you can try to embed with large language models and make sense of the semantics of science. And also, besides, of course, the embedding I mentioned already, AI, of course, we have tools, advanced tools from network science, data sciences, and of course, AI machine learning that allow us to analyze these things better. And the things that you can do with that are countless. Citation dynamics is where I started. Citation networks have been studied for a long time. The first citation network was built by the Solar Prize in the 60s. Science paper, collaboration dynamics, evolution of science and topics, career dynamics, scientific excellence, innovation, and so on. So I studied, I would say, a lot of these things, but today I wanted to focus on some of the things of science that I find disturbing. And probably you're already aware of some of these, at least anecdotally. So I'm going to put together a collection of some empirical results that we found over the years, recently, but also some time ago, that undermine somehow the way science proceeds and sometimes also its reputation. So these are the things I'm going to talk to you about today. Publish or perish, this motto, that's a kind of, it's a big burden on our shoulder, this thing that you have to feel, that you have to produce to show that you're alive. And the resulting attention decay towards the science that you produce. And then something more recent, very recent, some of which is even in progress, about the impact that COVID had on science. And finally, as a way to close, also kind of an older result of ours about scientific progress, as shown by what I like to call the Nobel delay. But let me start with publish or perish. Probably seen diagrams like this several times. Perhaps not this one, because this one includes all the 6 data sets that you can have access to one way or the other. OpenAlex, which is the ancestor of Microsoft Academic Graph, Web of Science, Scopus, Dimensions, MIT Scholar, Google Scholar. There is a log scale on the y-axis, so you see the number of publications per year, published every year, has been growing very fast. Pretty much since, ever. There are, of course, important changes. There were dips here, Second World War, First World War. Obviously, there were other priorities at that time, but other than that, instead, it's been fairly monotonic, especially after World War II. So is it good or bad that there is this explosive number of publications? Does it translate into real progress? The answer is actually no. I can give you some evidence, but let me show you one of the consequences of this. This is a paper I published several years ago with Bernardo Huberman and others, and Kim Okaski. So what you see here, the top 10% most cited papers of physics and biology, and it's a normalized scale. You're dividing the number of citations that these papers get every year by the peak value, the highest value that they ever get. So in principle, of course, the thing for each paper is normalized to 1, but since, of course, not all of them peak at the same time, when you make the average, then you see this peak here at the beginning. So there is a peak of attention in the first few years, and then, of course, the thing fades away. Goes for physics, goes for biology, and it's been going like this pretty much for many years. You see each color corresponds to a different year, publication year. You may notice from the colors then that the more recent papers are forgotten more quickly. So why is that? I mean, probably we are overwhelmed. Try to propose some alternatives here. But how do you quantify that? I mean, of course, you can show this nice picture. You can have a sense that, of course, the darker lines are ending earlier. The way we decided to evaluate that was by computing the half-life of a paper, which is, there are many operational definitions. They wanted to use the time after publication since the last time the paper collects more than half of the peak citation value. So the last time that the paper after publication collects half of the peak citation value, that's going to be basically kind of the half-life. And if you do that, you see that for these 4 different disciplines, this half-life object here is going down over time. So kind of confirms quantitatively what we've seen before. So papers are getting forgotten faster. That's what we call attention decay. And then one thing that we did just for fun is say, I mean, maybe this is not the real, but this is actually real time, right? So really measuring in how many years have been, have gone between publication and this final moment, like this half-life or the time of the paper. What if we use a different unit? Like, for instance, the number of papers. If we use the number of papers, just to say that, I measure time based on how many papers are published, not just in days, years, hours, because that's my unit. That's the thing that is important for me, to retain or forget things. If I do that, if I basically rescale, instead of expressing this number in terms of the number of years, I express it in terms of how many papers were published in that interval, I get this diagram that you see below. This is the same curves in which the very same thing is just expressed in terms of the number of publications. And this is, of course, a very coarse way of defining time, if you want. But you see, for instance, chemistry and physics are basically flat on this scale. So in this respect, actually, there is no real attention decay. Attention decay is really measured in terms of how many items are published. So the effective shrinkage of this time in real-time units is just due to the fact that the number of publications is growing so fast. Bless you. There were some quotes about this. After that, this is my favorite. New study finds that there are too many scientific studies. Kind of nice contradiction, but yeah, exactly. That's a thing. It's another one. So, but I have a surprise for you about this. This is the same curve I showed you before, but I showed it to you until 2013. If you compute it today, because this literally was computed last week, you see that there is something historic happening here. The number of publications is saturating for the first time in history. Look, I mean, these are different data sets, right? The Web of Science corpus, they have their own index. They don't cover everything. They decide which journals deserve to be indexed by them or not. So they have ways to manipulate this. But the comprehensive sources like Google Scholar, OpenAlex, and Semantic Scholar try to catch everything, including technical reports and preprints. So why is that? Are we getting to carrying capacity, or are we, don't know, finally trading off and preferring quality over quantity? Because the number of researchers is still growing at the same pace. We have also plots about this. I'm not going to show it today. This is just an insight about the last few years. So dimension is a little bit exceptional. Excuse me? For the bigger ones too, yeah. For the OpenAlex, the blue one, the gray one, and the black one, Semantic, and what is it? And Google Scholar, yes. No, Web of Science only index published papers in their journals, in their index journals. Yeah. So then you can ask yourself, I mean, is it temporary? I mean, it's not that in the previous 100 years, nothing happened, right? We got the PC, the personal computers, internet, and yet you see this very nice, smooth exponential growth. So is the AI going to change everything? Are we in a phase in which we started to get familiar with this new tool, and then once we do, then things will blow up again? I had to get back to you in 5 years, maybe. But if you want to take a look at what happens in the last year, and it seems that people are already heavily using chatbots and large language models in their research, probably mostly for writing, creating tables and other things. This is monthly. So for each dot here, which is now 1 month, you have how many papers have been published in the previous 12 months. This is dimensions. This is OpenAlex. So the same thing for the 2 different data sets. For OpenAlex, things have been flat for a long time. You see the last year doesn't seem very explosive with respect to, if there was any impact of AI in productivity, these diagrams don't show it. Maybe they will show it in 5 years, please. I'm going to talk about COVID soon. Yeah, so I have something to say about that. But, otherwise, Dirk is very strict, this German, just taking this time away from my presentations. But, we can have a longer session after that. Yeah, I'm going to talk about that too. That's a good point. Okay, so that's the first thing. So we're saturating. We are reaching carrying capacity. That's interesting. It's never happened. So you can ask yourself, why is it happening? A lot of journals have been shut down because of misconduct. You've probably heard. I don't want to make any labels here, but probably seen things and so on. And a record number of retraction last year, the number has been growing very fast. But that cannot be the reason. We found out it is a very tiny amount of the whole science body. Okay, this is more recent stuff. You talk about COVID, let's talk about COVID. Another thing that I call a dysfunction in science, and of course we have one of the world experts here that studied COVID better than anybody else. Alessandro. This is a paper a comment actually that we published recently in Nature Human Behavior, where we try to answer this question. Were the people who wrote COVID papers competent? I mean, it's kind of brutal. What were the expertise of people who published COVID papers with the label COVID that you can get from this data set, OpenAlex, that we used? We defined scholars in 3 categories. The first one is outbreak scientists, researchers belonging to the outbreak science community, people like Alessandro, epidemic modeling, virologists, infectious disease experts. Then there were bellwethers. These are researchers from fields different from the ones above that started making COVID papers, as you probably see, because this whole thing was motivated by anecdotal evidence, where we saw so many things, including a lot of colleagues of ours starting making epidemic curves without having really the background for that, except some basic mathematical modeling. So we wanted basically to quantify this effect, which hence the term COVID amateurs. And the final one, the newcomers, younger researchers still in training. This could be just young PhD students that didn't have a past. They didn't publish anything. And of course, they don't have a previous record before COVID. So what we found, and I'll give you just the evidence here, the main thing, between 2020 and 2022, only 7.7% of authors of COVID papers were outbreak scientists. And more than 60% of the papers published on COVID did not have a single expert in epidemic modeling, infectious diseases, virology, or the above. We have, of course, to select the terms to define this category. So consequences of this, and I think probably I don't have to struggle to convince you of this, a lot of papers with poor quality, jamming the system and diminishing the credibility of science. And we've seen some of them. I don't want to make any names here, the hydroxychloroquine things and so on. We've seen that actually those were supposed to be experts. And but also you lost the value, but the downside is that you lost the valuable expertise. Some of these people could have helped, in terms of epidemic modeling, fast simulations, expertise in data science. So what was not happening, they were not able, because of course people were super busy, I know Alessandro certainly was, to reach out to the expert to get some domain expertise in their work. So they just went on by themselves. And one thing that one can do to avoid that is somehow to get these people in contact with each other. We're considering creating a platform like LinkedIn, that's for scientists, in which you can upload all your publications, define your expertise, also using large language models to help people to find each other when they start a new project. But that's the future. The other thing that we're studying, and this is work in progress, we are submitting it anytime, and I have something potentially interesting for you at the end that we have to double check. Is that did the COVID-19 pandemic change the way scientists collaborate? What's your feeling? Did it change? Do you feel? Yeah, let me tell you in which way it changed. But the result is scientists collaborate more often with colleagues from different institutions by online interaction. We all became Zoom experts or Teams experts because we were forced to do that. There was no other way to communicate. So we are so comfortable. Perhaps you have to check yourself what's the ratio of real in-person meetings versus online meetings that you're holding now compared to 5 years ago. You will see that the number of online meetings is growing, and you have online meetings even with collaborators in the same institution. But this diagram here shows that in the breakdown between collaborations within institution, collaboration between institutions, you see here after COVID, there was a big, it's a sharp change. Of course, the numbers are not huge. And you see the inter-institution collaborations are going down and inter-institutions are going up. This is also verified by the average team distance. So the average distance between any two institutions of a collaboration as a function of time. You see here, it was kind of already growing, which means that on average, people were collaborating more and more remote. But after COVID, it's jumping up because of this sudden increase in online interactions, I suppose. By the way, you see that there is a shift here. We worked with archive preprints to make sure that we can catch the immediacy of science before the paper is actually published. But the paper is produced before its publication. So this shift that you see is probably not really real, right? Because the paper was produced already, for instance, in this case, during COVID time. So it's kind of difficult, but that's the best thing we could do, usually working with preprints. And then we try to model how, and that's the only thing I'm saying about modeling, how institutions form collaboration with each other. Basically, this is the only thing it has to do with networks. This is the probability that two people in different institutions, I and J, are collaborating. And you have kind of a gravity law, dependence on distance with an exponent alpha. This is the distance between the institution. And this is the geometric mean of the strength, which tells you basically how many times, how many collaborations were based on that institution. That would be the SI. And if two people collaborate in the same institution, you have that this thing becomes proportional to the strength of the institution. So how many collaboration, how strong the institution is in terms of how many papers basically produces. And this comes from this diagram that you see here that shows that basically the number of collaboration within institutions grows, of course, with the strength of the institution. So that's because of this that we assume this linearity here and that we assume the square root here. So basically the only assumptions we're making here is that there is a power law decay with distance. And the only parameter is alpha because this D0 was fixed at about 100 kilometers. So we didn't touch it after we settled on that. And these are the curves that I showed you before. The fraction of inter-institutional collaboration is a function of time and the average team distance. And you see that actually the model fits the data very well. And with only one parameter, which is this alpha, which after COVID went down quite abruptly, showing that, of course, lower alpha means that the longer distances are more likely. So it's basically just a confirmation of what you've seen before. The thing which is probably a little bit more controversial about this, we're double checking this, we may have another year worth of data to add to that, is that it seems that the impact of the papers produced after COVID is lower than the impact it was before. So impact went down. And like I said, I mean, unfortunately, this meeting was not at the end of the month because by that time I could probably have added another year worth of data. We are checking this now because we have more recent snapshots from OpenAlex. We started this project 2 years ago. So what's the reason? I mean, assuming that this is true, and like I said, we're double checking. So I'm just leaving it to you like this, hopefully I can confirm this soon. And maybe it's gonna bounce back, we don't know. For instance, we will know at least what happened in the year 2023 very soon. But what's the reason? I don't know. You can have your own interpretation. There are some recent studies, including studies published in an important journal like this one. I don't know these people, but I read the paper. They show that online interactions penalize creativity. The fact that, it's still better to interact with people in person. There is more improvisation. There are the higher probability of leaps of somehow, bumping into new ideas. These are social scientists. They really tested two different settings, online and offline. So I don't know, is this the reason? We'll see. And finally, this is something to end on a funny note, but this is a project that we did a few years ago about Nobels, all about progress, the progress in science. Has it been going up or stable, or is going down? So one way to measure that out of many, at least it looked like a good idea back then, and the trend is being the same also in the last 10 years since we made the study. There is new data that show that, is how long it takes for people to get a Nobel Prize when they do a big splash discovery. So this is exactly what you see here. On the x-axis, you have the year of the Nobel Award, and on the y-axis, you see how many years it took to get the prize from the publications that were attached to the award, which we had actually to recover manually. It took months, 6 people. It was a long time. Now it's much easier. I think you can ask ChatGPT, can make a nice table comparable with ours in a few seconds. But we didn't have this tool available. These are the 3 categories in science: physics, chemistry, and physiology or medicine. The bigger bullets are 5 years averages to try to avoid, of course, the noise. You may recognize some of the discovery. The Higgs boson is there. It was like 48 years delay. And the fit is exponential, actually. It was better than the linear one. Slight exponential is better than the linear one. Among the other consequences of this, there is this fact here, which is really practical, and it has an importance for the definition of the Nobel Foundation itself. Here, this is the age at which these people got the Nobel, whereas this thing is the projected life expectancy of US citizens in, if you take the data, in the next century. And this crossing here is a little disturbing because, as you probably know, you cannot get a Nobel Prize unless you're alive at the time of the announcement, when you get the call. There was a case in the last few years in which actually the laureate was alive when he got the call and he died before the ceremony, like a month later. Was already hospitalized, but at least he could get the big news. So this is not good because unless you change the statute, there's going to be a problem. So extinction of Nobelists, a lot of attention. I'm going to show you some of the covers here, but the main thing is that why is this happening? What does it tell us about science? So what can we learn from this? And actually, this is the only case in my life, and I've been around for a while, in which the same effect that I just showed you can be explained in 2 opposite ways. There is the way that I tend to agree with, see that also because at least I checked some of the Nobel Prize in physics. I was actually at 2 Nobel lectures when I was in Sweden. The one for the neutrino. I also saw John Nash giving his Nobel lecture. It was economics though. So progress is slowing down because you have to get back and back forward, backwards and backwards, in order to find worthy winners. So that would be the pessimistic outlook, and it's more in line with what I think. I'm done. This is the last slide. There is another one after that. Or the other one, instead they say, no, it's the other way around. There are many worthy winners. So you have to take a number and wait until your turn comes. So it's kind of interesting. I find also a nice sociological experiment. The same thing can be explained in two opposite ways. And of course, when it came out, there was a big discussion. Science is running out of things to discover. Dying for a Nobel, winners' neck prizes at other ages. Scientists sound alarm or long wait for Nobel Prize, and so on and others. Okay, let me summarize here. I gave a lot of facts, some opinions. The rest will have to be verified, including some of the facts, especially the drop in the impact factor of papers after COVID. All of them, by the way, they were not COVID papers. This is all of science, when I show you the thing, talking about the whole thing. So publish or perish, papers are forgotten faster and faster. This is a fact. However, the natural unit of time for scholars seems to be connected, if not exactly equal, to the number of published items. In the sense that, the more stuff is out there, the more we focus on this, and this is a more natural way to measure time in our mind. However, for the first time in history, it seems that the growth of the number of scientific papers is stalling. It's even going down, according to some of these data sets. We try to cover all of them. So why? Why is this happening? And is AI going to change this? Is it going to blow things up again? We'll have to wait a few years for this, but in the last year, nothing significant has happened. We are still at the beginning. We're more powerful. People get more familiar. Probably things will change again, but that's where we are now. The other thing is that there was an army of amateurs during COVID that published papers without knowing the first thing about epidemic diseases or epidemic modeling. And of course, Alessandro probably has his own anecdotic evidence of this. We need more awareness of people's expertise, better ways for people to find each other, form teams that can get the result, And of course, it's good, it's nice, it's free. If somebody publish a paper, is great. That's a good thing about science, that you're free. But it can also create a big problem. It can jam the system, can decrease the reputation. Also, the people who do the right thing, they have the right knowledge to do that. And thanks, I was just finishing. Scientists collaborate more and more long distance after COVID. This is a fact. But impact seems to have decreased. This is almost a fact. Let me double check that. We have this recent snapshot and see what happened in the last years. It could be temporary. So a good question is why? There are other studies on top of the one I showed you that indicate that international collaboration lead to less disruptive works, which is connected to creativity, innovation, and so on. So is this perhaps the reason? Shall we have more meetings like this? More online with people? Yes, for sure. Less birthdays, more meetings. And finally, fast-growing delay between publication of Nobel discovery and reception of the prize. Why? Does it mean that the progress is slowing down? But as I told you, some people are just seeing a positive light in that. And that's, for instance, the Shun Wang and Laszlo Barabasi put the opposite interpretation. They quote this, they show even the picture in their book, Science of Science, but they have more optimistic spirit. I see in the physics data, I'm less optimistic. Thanks a lot, everybody, and happy birthday.